Hello friend. Now last time we have seen the indeterminate forms. Now which forms are called the indeterminate forms? These are the forms. The first form 0 by 0, infinity upon infinity, which is the division form. Second form infinity minus infinity. Third form the product form 0 with infinity or infinity with 0. And fourth type of indeterminate form, it is function raised to another function. It is 0 raised to 0 or infinity raised to 0 or 1 raised to infinity. These are called the indeterminate form. Indeterminate and second is determined form. There are two forms. One is the determined form and this is the second form, which is the indeterminate form. So see, first of all, remember these four forms. The division form 0 by 0 and infinity upon infinity. Second form, it is about the subtraction or addition, infinity minus infinity. Third form, it is in terms of product, infinity with 0 or 0 with infinity. And fourth type of indeterminate form, it is function raised to another function. It is 0 raised to 0, infinity raised to 0 and 1 raised to infinity. These forms are called the indeterminate forms. Now also we have seen the L-Hospital rule, or this is called the L'Hopital rule. Don't call it as the hospital rule. It is the L-Hospital rule or it is the L'Hopital rule, or we can just simply say that it is LH rule. Now see what is this L'Hopital rule. This is the statement of L'Hopital rule. If the limit form of some division, if that is either in 0 by 0 or infinity upon infinity form. See what is the requirement for the applicability of L-Hospital rule. First of all, we required the division form. Limit form, it should be the division form. If the limit form of some division, if that is either in 0 by 0 or infinity upon infinity form, then we can apply the L-Hospital rule. And according to this rule, this limit form, this is given by limit x tends to a of fx upon gx. This is given by the formula limit x tends to a. Just write the derivative of fx divided by, write the separate derivative of denominator. What is this rule? If the limit form of some division, if that is either in 0 by 0 or infinity upon infinity, then we can apply the L-Hospital rule. And according to this L'Hopital rule, this particular limit is given by the formula. Just take the separate derivative. Derivative of fx, it is f dash x, and derivative of gx, it is g dash x. Don't apply u upon v rule. So this rule, it is called the L-Hospital rule or it is called the L'Hopital rule. Now see, these are the type of indeterminate form. The first form 0 by 0 and infinity upon infinity. For this particular form, we can apply the L-Hospital rule. Now for the remaining term or for the remaining type, which are the type? For infinity minus infinity, for the product 0 into infinity or infinity into 0, and for this is the third type, 1 raised to infinity, 0 raised to infinity, and 0 raised to 0 and infinity raised to 0. For division type, for 0 by 0 and infinity upon infinity, for such a time we can easily apply the L-Hospital rule. But for the remaining term, infinity minus infinity, for the product term or for the function raised to function term, we have to convert this form in terms of division form. See what is the process. If the limit form is 0 by 0 and infinity upon infinity, we can easily apply the L'Hopital rule. But for any other cases, for consider suppose the limit form will be suppose the infinity minus infinity form. If the limit form contains the product or if the limit form contains the function raised to function, that means for these three remaining form, we cannot apply the L'Hopital rule. So what is the process? Anyhow, convert this form in terms of the division form. If the form is division form, then it is the proper form. We can easily apply this L'Hopital rule. But for any other remaining cases, we have to convert this form. We have to convert this form either in terms of 0 by 0 or infinity upon infinity. Now let us take this next topic which contains the product. We have already seen 5 examples on 0 by 0 and infinity upon infinity topic. Now see, this is the example. Evaluate limit x tends to 0, x into log x. Now see, if we observe this limit function, then we can easily say that this limit form contains certain product. Now see what is the process. If the limit form contains the product, then we have to convert this form anyhow either into 0 by 0 or infinity upon infinity. This is the process. If the limit form contains suppose the product, then what is the method? Anyhow convert this product either in terms of 0 by 0 or infinity upon infinity. If the limit form contains suppose some subtraction, then again the process it is same. Okay, anyhow convert this form in terms of division, or this is the third topic. If the limit form contains function raised to function, then what is the process? Convert this form either in terms of 0 by 0 or infinity upon infinity. So first of all, remember this. If the limit form contains suppose the division form, then we can directly apply the L'Hopital rule. But for any other cases, these are the remaining cases. If the limit contains the product form, this is the next topic. If the limit form contains the infinity minus infinity, or the limit form contains the function raised to another function. So in all these cases, what is the method? Anyhow convert this form either in terms of 0 by 0 or infinity upon infinity. So see, so this is the solution. So this is the given limit. Limit x tends to 0, x into log x. Now this is not our proper form. This is the product form. What is our proper form? This L'Hopital rule. For L'Hopital rule, we required the division form. Now this is not a division. So what is the method? Anyhow convert this form in terms of division form. So see what is the method. Either transform this first term in denominator so as to get some numerator divided by denominator, or we can transform this second term in denominator. See what is the method. How to convert product in terms of division. Either transform this first term in denominator, or we can transform this second term in denominator. So let us transform this first term in denominator. So this is limit x tends to 0. Now this is something easy term. So just write down log x as it is and transform this first term in denominator, so it becomes 1 upon x. If we transform this x in denominator, then we get this 1 upon x. Now obviously this is the division form. Now if we put suppose x equal to 0, then log 0 it will be infinity. Put x equal to 0 in denominator, then 1 upon 0 it is again infinity. So write down this is the proper form. So right here, this is 0 by 0 form. So this is the required form, 0 by 0 form. So if the form is 0 by 0 or infinity upon infinity, then we can directly apply the L'Hopital rule, or it is called the L'Hopital rule. So see, this is the method. If the limit form contains some product, then what is the method? Either transform this first term in denominator, or we can transform this second term in denominator so as to get the division form. So this is the division form, which is the proper form 0 by 0 form. So we can apply now the L'Hopital rule. So write down this is equal to limit x tends to 0. Now say what is L'Hopital rule? Just take the separate derivative of numerator divided by derivative of denominator. Don't apply the division rule. So derivative of log x, it is 1 upon x divided by derivative of 1 upon x, it is minus 1 upon x square. So just give the reason by L'Hopital rule. This s, it is the silent term. It is called L'Hopital rule. So just simplify. So this is equal to limit x tends to 0. Now xx get cancelled. This is minus x. Put x equal to 0. So this is the limit. So see, just remember this technique. If the limit form contains the product form, then anyhow convert this product in terms of division. Either it is 0 by 0 form or infinity upon infinity form, so as to we can apply the L'Hopital rule. Write down the second example. Evaluate limit x tends to 1 1 minus x into tan pi x divided by 2. So see, this is the same form. This limit form contains the product form. So see, what is the method? If the limit form contains the product, then what is the method? Anyhow, we have to convert this form in terms of either 0 by 0 or infinity upon infinity. If the form is 0 by 0 or infinity upon infinity form, then and then we can apply directly L'Hopital rule. So write down the solution. So this is limit x tends to 1. Now write down this first term as it is 1 minus x, and if we transform this second term in denominator, then this tan becomes cot pi x divided by 2. What is the method? Either transform this first term in denominator, so this is the form tan pi x divided by 2. If we transform this first term in denominator, then it will be 1 upon 1 minus x. Or we can transform this second term in denominator, so this is the format 1 minus x divided by 1 upon tan pi x divided by 2. 1 upon tan, or we can simply write cot pi x divided by 2. So see, this is the method. If the limit form contains the product, then we have to convert this product in terms of division. Now if you put suppose x equal to 1, 1 minus 1, this numerator will be 0. And if you put x equal to 1 in denominator, cot pi by 2, this is 0. So write the form, this is 0 by 0 form. So if the form is 0 by 0, then we can directly apply the L'Hopital rule. So this is equal to limit x tends to 1. So what is the L'Hopital rule? Just take the separate derivative of numerator and take the separate derivative of denominator. Don't apply u upon v rule. So derivative of 1, it is 0, minus derivative of x, it is 1, divided by derivative of cot x. Derivative of cot x is minus cosec square x. This is the formula. Derivative of cot x, it is minus cosec square x. So use this formula into, According to chain rule, multiply by coefficient of x. So coefficient of x will be pi by 2 and just give the reason by L hospital rule. So just simplify, this is equal to limit x tends to 1. Now this minus and minus become plus. 1 upon pi by 2, so this is 2 upon pi, and 1 upon cosec means it is sine square pi x divided by 2. So see, what is this simplification? Minus and minus become positive, it will get plus sign. 1 upon pi by 2, so it is 2 upon pi, and 1 upon cosec means it is sine, so 1 upon cosec square means it is sine square. Now put x equal to 1, just put the values and find out the limit. Now if you put x equal to 1, then this is sine pi by 2. Sine 90 it is 1, so this is 2 by pi into 1, so this is the final answer, this is 2 divided by pi. Write down third example. Evaluate limit x tends to a log 2 minus x upon a into cot of x minus a. So write down the solution and write down the same example. Limit x tends to a, this is log of 2 minus x upon a into cot of x minus a. Now see, this is again the similar form. The limit form contains the product form. So see, what is the method? If the limit form contains the division form, either it is 0 by 0 or infinity upon infinity, then we can directly apply the L hospital rule. But for any other cases, for the product form, either it is 0 into infinity or infinity into 0, we have to convert this product in terms of division. So first of all, convert this form in terms of division. So write down this is equal to limit x tends to a So see, what is the method? Either transform this first term in denominator or transform second term in denominator. So write down this first term as it is log of 2 minus x upon a divided by, now transform this trigonometric term in denominator. So this cot becomes tan of x minus a, or we can write like this, log of 2 minus x upon a divided by, now if we transform this trigonometric term in denominator, then it becomes 1 upon cot. So instead of 1 upon cot, we can write here tan x minus a. So this is the proper form, which is the division form. Now say if we put x equal to a, then a upon a it is 1, 2 minus 1 it is 1. Log 1 it is 0, so numerator it is 0. Put x equal to a in denominator, a minus a it is 0, so tan 0 it is 0. So write down the proper form. This is our standard form, which is 0 by 0 form. So if the form, if it is 0 by 0 form, then what is the method? We can apply the L hospital rule. So write down this is equal to limit x tends to a. So what is L'Hopital rule? Just take the separate derivative. Derivative of log x, it is 1 upon x. This is the structure. Derivative of log function, it is 1 upon x. So use this standard formula. Derivative of log function, it is 1 upon 2 minus x upon a into, according to chain rule, multiply by derivative of this inner function. Derivative of 2, it is 0 minus 1 upon a, this is constant term, and derivative of x, this is 1. So this is our standard formula. Derivative of log function, it is 1 upon same term into, according to chain rule, multiply by derivative of this inner function. So derivative of constant to it is 0, 1 upon a it is constant, and derivative of x it is 1, divided by derivative of tan x, it is sec square x. So this is sec square x minus a, and just give the reason, this is by L'Hopital rule. So this is equal to, now just put x equal to a and find out the answer. If you put x equal to a in denominator, then a minus a it is 0, sec 0 it is 1, so denominator it is 1. Put x equal to a in numerator, so a upon a it is 1, so 2 minus 1 it is 1, into this is minus 1 upon a, and put x equal to a in denominator, sec 0 it is 1, so this is the final answer, this is minus 1 upon a. Now write down the fourth example on same form. Evaluate limit x tends to 0, x into tan of pi by 2 minus x. So write down the solution and write down the same problem. There's a limit x tends to 0, x into tan pi by 2 minus x. Now see, this limit form contains the same form, which is the product form. So again, what is the method? Convert this product either into 0 by 0 or convert this product in terms of infinity divided by infinity. So write down this is equal to limit x tends to 0. Now write down this first algebraic term as it is x, and transform this trigonometric function in denominator. This tan becomes cot of pi by 2 minus x. Now if you put x equal to 0 in numerator, so this is 0. Put x equal to 0 in denominator, cot pi by 2 it is again 0. So write down the proper form, this is 0 by 0 form. So this is equal to limit x tends to 0. Now apply L'Hopital rule. What is L'Hopital rule? Just take the separate derivative, derivative of numerator divided by derivative of denominator. So derivative of numerator it is 1 divided by derivative of denominator. Derivative of cot x it is minus cosec square pi by 2 minus x. Derivative of cot x it is given by minus cosec square x into, according to chain rule, multiply by this coefficient of x, which is minus 1. So just give the reason by L'Hopital rule. So this is equal to limit x tends to 0. Now this minus and minus become plus, and 1 upon cosec square, so this is sine square pi by 2 minus x. Now if you put x equal to 0 in this term, then we get a solution. Sine 90 it is 1, so this is the final answer, which is 1. So remember this form. If the limit form contains the product form, then what is the method? Anyhow convert this product form either in terms of 0 by 0 or infinity upon infinity, so that we can apply the L'Hopital rule. Thank you.